Embedding a professional identity framework into faculty with several disciplines, a case study. Authors Dr. Neil Cook and Professor Kamal Hawash from the University of Birmingham. Presentation given by Neil Cook. Introduction. How can students' identification as engineers be explicitly encouraged and successfully embedded into engineering schools, and what is the benefit? In education, how students see themselves as engineers influences their academic performance and career choice. Our incentive is to better understand how to forge engineering identity in an engineering school in order to improve these outcomes. We present a case study for embedding a professional identity framework into an engineering faculty that runs programs for several disciplines at undergraduate and postgraduate level. A key feature of this work is that the framework consists of a skills inventory grouped into a novel categorization scheme of 4 dimensions. Background. Defining and developing engineering identity has gained interest over the last decade. Many studies use Carlone and Johnson's conceptual model. This comprises 3 overlapping aspects of identity: social, personal and domain. Domain identity is dependent on a student's perceived performance, recognition, interest and competence in their subject. Structure, our framework. We build on Carlone and Johnson's model for student identity and embed it into our faculty. Our embedding framework, on the right, comprises of 4 dimensions. Each dimension has an underlying skills inventory. The dimensions are accreditation, the accredited degree learning outcomes, institution, the general skills and competencies desired by an institution for all its students, habits of mind, the thinking patterns associated with engineering professionals, and career, consideration of future identity and career. To embed the framework into our faculty, our strategy follows activities outlined in the 5 dimensions of growth proposed by Costa and Kallick, who pioneered the habits of mind approach. These include exploring meanings through student and academic staff teaching exercises, increasing alertness by adding environmental cues designed to activate engagement in the virtual and physical learning spaces, and value extending, which is existing reward and recognition systems are incorporated into the framework. Framework evaluation. We evaluate our framework by studying 3 aspects. 1. Student skills ratings. 2. Staff engagement and comprehension. And 3. Students' reflection on their identity progression. Student skills ratings. 513 students across all years in the undergraduate cohort rated themselves against each skill in each dimension using a 5-point Likert scale. A summary is shown on the graph below. There are significant differences in student ratings across cohorts and their groupings. For example, older year groups are more conservative in estimating their skill level. This may be demonstrating the Dunning-Kruger effect, where low ability people overestimate their ability. Student self-rating of skills encourages engagement with the framework and allows us to monitor the impact of quality improvement initiatives through skill measure. 2. Staff engagement and comprehension. Engagement of teaching staff is key to embedding the framework. We ask them to voluntarily redraft their module descriptions for the framework. These redrafted descriptions were binary coded in 3 axes: whether they identify the relevant skills, whether they identify the relevant dimensions, and whether they contextualize skills and dimensions to their teaching content. We found that staff find it easier to relate their modules to identity when considering 4 dimensions in addition to or instead of the detailed skill inventories. This demonstrates the value of dimensions in the framework. 3. Student reflections on their engineering identity progression. The 513 students wrote reflections on their engineering identity across each of the 4 dimensions. This resulted in 2,029 reflective commentaries. A sample of a student reflection is shown in the table below. Using automatic natural language processing techniques from data mining, we compare vocabulary usage in the responses for each dimension. We reduce morphological variation in the responses through the NLP techniques stemming and lemmatization. This allows us to better compare different word count distributions. An example of the word count distributions for each dimension are shown below. The term frequency inverse document frequency, TF-IDF, is then computed for each word. The words TF-IDFs help us to determine whether the dimensions are comprehended by the students as distinct constructs. Our results support this, since the top 4 words in the table below correspond to different dimensions. These results also help us to modify our word use when describing the skills inventories to reduce ambiguities. Summary. In this work, we proposed a professional identity framework for engineering students, grouping measurable skills under the 4 dimensions of accreditation, institution, habits of mind, and career. We use automatic natural language processing of students' reflective commentaries to measure comprehension and engagement with the framework across a large body of students. We can use this framework to broaden programme development beyond meeting accreditation requirements, provide educators with perspectives to reframe their teaching to consider identity formation, and help students motivate their study and career choices. Thank you for watching. Please contact me if you would like further information. There is also a video available on YouTube which is provided to students which introduces them to the framework.